Okay, now I would like to illustrate just a general procedure for solving the systems by substitution, and here it is. Number one, choose an equation and solve for a variable. Number two, substitute in the other equation using information from step one. The moral here is information always flows from one equation into the next, never back into itself, okay? So if you solve for a variable, plug that information into the other equation. Number three, use the result from step two to determine the value of the remaining variable. And number four, finally, check your solution. So let me go through that general procedure here just to highlight in detail what's going on. And we'll see how this works, and hopefully I have enough room to fit it all here. So step one, choose an equation and solve for a variable. I have two choices because there are two equations. And I have two choices even after that because I have two variables. So I think I'll choose equation number one, the top one, let's say, and I think I'll solve for x. So you'll find out as you do this and as you go through these problems that some choices are definitely better than others, and we'll try to identify those along the way. For now, it is not obvious to me that one choice is better than the other, so I'm going to choose equation number one, and I'm going to solve for x. So if I want to solve for x, I'm going to subtract y from both sides, and that gives me x is equal to 10 minus y. That's step one. Step number two. Now I'm going to use the information from this equation that I ended up with by solving for x, and I'm going to plug that into the other equation. It's got to go into the other equation, never back into itself. So this would give me then equation number two, or the bottom equation says 2x minus y equals 8. So I'm going to say 2x, which is 10 minus y, minus y equals 8. And you can see the substitution step right here where the 10 minus y replaced x in that second equation. And that's okay because that's what it's equal to from the first step. So now I'm going to distribute, combine, and solve. Distribute, that gives me 20 minus 2y minus y is equal to 8. This gives me 20 minus 3y is equal to 8. Let's subtract the 20 from both sides. Minus 20 here, minus 20 here. And that gives me negative 3y is equal to negative 12. Okay, let me just recopy that up here. Negative 3y is equal to negative 12. Then divide both sides by negative 3, and we can see that y is equal to 4. Okay. So that is my step number two. Step number three is use that to find the other variable. Boy, we're in a crunch here for space. For step number three, it doesn't really matter where you plug this 4 into. What I mean is, you can plug that into either one of those original equations, and that's okay. Previously, when you're doing your original substitution, it really does matter that you flow information from one equation into the next. But as soon as you have your value here, or your number, go ahead and replace that in either one of the original equations, and you're okay. So I'm just going to use the first equation, x plus y equals 10, with my value of y equals 4. So then that would give me x plus 4 is equal to 10. Subtract 4 from both sides, and we can see x is equal to 6. And step 4. Boy, this is really cluttered, and I apologize for that. Step number 4 is we're simply going to check our solution. And to check it, remember that these two guys have to go together. They are together the solution to the system of equations, and they also have to work for both equations simultaneously. So to check the first equation, I'm going to say 6 plus 4 Does that equal 10? Yes, it does. So that one checks out. The next equation says 2x minus y equals 8. So let's say 2 times 6 minus 4. That comes out to 12 minus 4, which is indeed 8, which is what we were looking for. So it checks out with that equation as well, meaning that the solution to this system is x equals 6 and y equals 4 simultaneously. Let's take a look at a few more examples in another video.